hopefully that's a good sign for us. Today's presentation is on cut and carve demolition. Some of you may be fully aware what cut and carve is, but for those of you who aren't, in general terms, what it means is you're taking a structure and you're modifying it. So you're not completely demolishing it, you're generally looking to keep it. So this is a good example of a job in West London, Grammaphone Works, where the red is holes that have been cut in the slab. So there's lots of risers and bits and pieces. All the facade has been taken down. And interestingly, they wanted us to break back. This is your cut line here. Let me get the pointer on here. Where is it? Annotate. So that's the cut line was here. But we then had to break back all of this here to expose the rebar so they could tie the new slabs in. Sometimes they do it like that, sometimes they don't, but in this case, that's what they wanted. That's a good example of cut and carve. So I'm just trying to clear, there we go, right. Another good example was the works we did at Centrepoint House, or Centrepoint Tower in London. Again, you can see on the left-hand side shows everything in red had to be demolished and taken out. And then on the right-hand side is what went back in. So that's a good example of a cut and carve scheme. Facade retention, it can be classed as cut and carve, I suppose, because you are looking to keep a good proportion of structure. It's not typically what I would mean by cut and carve, but it's kind of along the same lines. You're looking to keep a large part of the existing structure. This is a very good example. So this is Birmingham New Street. This is the very top of the structure, the top level. Quite an old one, but also quite a good video of cut and carve in action. So you can see they put the atrium over the top, and then we're taking out what is now the nice big light concourse level at New Street Station. If you remember how the station used to be, it's quite a different beast now. But this is a good example of cut and carve where we're taking out significant parts of the structure whilst keeping the rest of the structure and keeping the building operational in this case at the same time. In this case, though, we were actually able to run some quite large plant because that building was built like the proverbial brick house. I think it was actually about a 20-ton machine. It was their custom-made, what was it called? The Mega Muncher. It was a combination of bits from JCB and a special dipper arm and a large attachment. There you go. So that's a good example of a cut and carve scheme. I don't want to play that again. Why has that gone like that? Sorry, it's just gone a bit weird. Give me 2 seconds. I'm just going to stop sharing and then reshare my screen because it looks a bit weird to me. Where's it gone? Why can you never find the button you want? There we go, right. Hang on, still not looking right. There we go, right, try again. There we go, right. That's back to how I wanted it, there we go, right. So we've seen that one. Another good example of an infrastructure scheme is Waterloo Station. Again, we did that with Coleman's a few years back now. Another good example where you can see on the screen here, the red is the area that had to be demolished, while the rest of the structure had to be maintained, including all the assets that are underneath Waterloo Station, such as the underground. So that's another good example of a cut and carve scheme with some significant temporary works and stability and propping issues to resolve. So just as a recap there, it's a substantial element of the structure is being retained for future use. That's when it becomes cut and carve. You have to consider how you're going to keep the structure stable. Just want to check something, sorry. Yeah, fine. Sorry, I just wanted to make sure you could see it properly. That was all. How we're going to keep things stable. We'll often require significant temporary works, and it's normally going to require a controlled demolition method. So you're going to be looking at cut and lift, top-down demolition or dismantling of the structure. Unlikely you'll get to use a high-reach machine or a large excavator, but it's possible. It depends completely on the structure and how much of the structure you're taking out, really. But generally, we're looking for a controlled demolition methodology. Now, the reason we end up doing it so often is planning constraints. So it's a lot easier to get a scheme through if you're not demolishing the whole structure and you're planning on keeping what's already there. It's looked on a bit more favourably by developers, by the planning committees. If the structure has been assessed and they think there's some redundancy in it, this is getting quite common now in London, is they'll look to see if they can put another floor on top of the existing building. This will typically be in CLT, cross-laminated timber, or a lightweight steel structure, and you can put 1, 2, maybe 3 extra floors on top of a structure, and then you might be messing around with the core, changing the lift shaft arrangement, changing stairs, that sort of thing. If you're changing the use of the structure, so potentially going forward, if people don't go back to the office, then you'll be potentially looking at changing office buildings into residential, and then there'll be a lot of messing around with cut and carve of buildings to change the use, I would expect. If your facade or the structure is of historical importance, then you're probably not going to get away with demolishing it, therefore you're going to have to keep it. And the other one that's becoming increasingly more important is environmental considerations. So people are certainly being considered far more detail than it was even going back a year or two ago. How your carbon footprint is, how it looks for the structure. Obviously, if you can keep a part of the structure and build upon that, it's going to cost you a lot less, not just in money, but in carbon, than if you demolish it all and start again from scratch. So it's something I think that's going to increase as we go forward, the amount of cut and carve work as opposed to full demolition. So there's a few things that I've identified that make cut and carve different to normal demolition works. And that is the need to consider serviceability. Normally when we're demolishing a structure, we're not concerned with serviceability a great deal. We want to make sure the structure is not going to fail when we're doing the demolition, and that's pretty much it. A thing called load history needs to be considered, which I'll go through in a bit more detail shortly. Deflection becomes far more important, and deflection here, I'm thinking if you're propping large parts of the structure, the settlement or the movement of those props is quite an important issue, and knowing how to get around it and what to do about it. Stability is more likely to be an issue as well when you're doing cut and carve. Quite often the core is what's removed from these structures because they want to put in a bigger lift or a faster lift, or they need to make the lift shaft taller. So you end up, one of the first things that goes is the core. So you've got to put in temporary stability to the structure. Whereas if you're doing the traditional demolition, you're more likely to be able to work towards a core or the stability systems in the existing structure and maintain stability in that way. And then the other thing that becomes more important is how does the follow-on contractor complete the scheme? So traditional demo, you're going to leave the site either with basement backfilled or basement slab and first floor slabs or ground floor slabs still in. When it comes to cut and carve, you're going to do all the demolition. It's going to be handed over to the next contractor, or maybe you'll carry on with the works, but often another contractor comes in to then do the rebuild, and you've got there's that handover between how it's been left after the demolition and how the follow-on contractor is then going to work. So serviceability conditions. This is another job, or this is Grammaphone Works again, where we were cutting some large holes in the structure throughout all the different floor plates. Not a very tall structure. I think it's 3 stories in the basement. and lots of holes being cut. And we obviously had to consider serviceability conditions of the slabs during the demolition works for access by plant, men, materials, and propping to suit to make sure that the structure would be will remain stable throughout, and we're not going to cause any cracking. And we're not talking here about visible cracking, we're talking about exceeding the serviceability capacity of the slabs, which leads to micro cracking, which long term can lead to what's the word I'm looking for? Rusting of the reinforcement, and can affect the lifespan of the structure. So you have to think about making sure you're not exceeding serviceability, and considering how the change in removal of section of the slabs is going to affect the building. So for instance, here you can see the grey circles there are the columns. If you cut these big chunks out of the structure, you're changing significantly how the slab works, and you've got to make sure you put the props in the right place to pick up those loads. It's not the same as propping for back propping a structure for plant loadings. It's quite different because you're cutting and changing the load path within the structure. And there it is in reality. I think they actually changed the cut lines from the drawings we had there, but you get the idea that we're taking sections out of the structure. You can see there they've broken back and left the rebar protruding out of the slab. Obviously, with work like this, it's even more important that you know how the structure is going to behave and you have sufficient information regarding where the steel is, the grades of the steel, all of these things that we want anyway, but it becomes more important that you know how the structure is going to behave if you're trying to keep part of it. And it's equally important for the permanent works, the permanent works designer to know this, so they know that what they're doing is actually going to work. Just an example, we can see quite a lot of the Titan propping in there. Serviceability again becomes more important when you're looking at pre-stressed structures. So here, this is at New Street again, but it was quite a good example that sprung to mind. We had to run a lorry in over these beams, which were precast spanning grid line to grid line. Now, they had the ULS capacity to deal with the loadings, but they didn't have, they would have been pushed past their SLS capacities, which would have affected the longevity of the beams. Therefore, we had to prop it. Again, that's not something you would do if that was all being demolished and it had structural capacity for the load. You wouldn't worry about it. But because we're keeping it, it becomes something to be concerned. And there's just a picture of it in use. You obviously can't see the propping or the slab underneath, but that is the same location as you can see there with the beams coming out. Load history. This is a topic that we've come across many, many times with schemes that come in. People don't seem to grasp this concept. So if this is a section through a building, you've got a concrete column, floor slabs, and the demolition drawings say, right, you're taking that slab out and we want you to take out part of that column and that slab there, and then you're going to tie into that column. What they seem to miss is that if you break that out, all the dead load in the structure is now going through here. It has to. It's the only load path that's left. When you come along and you tie in your bit of concrete here, this green section in the column is not going to be carrying any dead load at all. It can't, because the dead load is already being carried through the reduced column section here. And that becomes very important when you start considering, is this tied in? And when they start assessing it in the permanent case and say, oh, well, we've got a full column back again, and then they spread the dead load and the live load through that full cross section, you can't. It's only this part here will carry the dead. This part here can only carry any live load that's applied up here. And it's we see it quite a lot. The only thing you can do is jack the structure, then cast that, then release it. That way you can put the dead load back through this section, the whole cross section. Similarly, steel beams or steel columns, if you want to strengthen a steel column and you need to strengthen it for dead and live, you've got no choice but to jack the structure. You've got to jack it to take the dead load off the column. You can then strengthen it. Then when you release the jacking, that dead load will go through that full structure. If you just go up to a column that's already carrying the full weight of the structure, then you put your strengthening on the side of it, that strengthening will only ever pick up any live load that's applied to it. It can't possibly pick up the dead load that's in the structure. And this idea that it can is nonsense, and it's, I say, we see it quite often with cut and carve and strengthening schemes. Deflection. So again, if you're keeping part of the structure and you've got maybe 7, 8, 9 floors of a structure and you're propping all of those back to ground level, the deflection at the top is going to be fairly significant, and it's something that needs to be considered. You've got to make sure your cut edges are adequately supported and that you're not overloading beams and columns because of the change in the load path through the structure. All of these things can lead to, well, not just you can lead to overloading, but also excess deflection that then becomes a problem when you get into the final stage where you're rebuilding the structure and you find that edges of your slabs have dropped 30, 40 mil from where they need to be. It's something that you need to think ahead and have a plan as to how you resolve it. It gets difficult because you've got the cross line between the demolition contractor finishing and the next contractor starting. Or if you're the demolition contractor who's doing the build as well, then you've got to start thinking about it earlier rather than getting to the end of the project and going, how do we put the new floors in now when everything's dropped? So this is an example of a scheme in London where I think it was 6 stories, this one. So the cumulative deflection in the propping wasn't insignificant by the time you got to the base. So the top floors would drop further. So we looked at a scheme to see how the deflection would change if you didn't jack. If you did no jacking and you just did everything without any jacking whatsoever, you'd end up with an overall change of 45 millimeters, which would be outside the scope for the work, the specification for the works. With the jacking in place, you can bring that down to 17 millimeters, which was within the allowance for the specification. Again, somewhere to, it's a big area to look at and make sure you've got a proposal in place as to how you're actually going to get around these issues. This one's just another example of using jacks to control deflections. Not really a cut and carve scheme this, but we had to take out a big shop front and put in a new steel support, and the only way to do it was to put in a system that had jacking in place. You couldn't physically put a deep enough beam or enough columns in place to pick up the load adequately. So the only solution was to use a smaller steels that had enough capacity but not enough stiffness to limit deflection, and then use jacks to control the deflection of the facade, and that worked quite well. It did the job nicely. So stability in all shapes and forms can come into play when you start doing cut and carve. So again, this is New Street, but it's a good example of where you have to start thinking. So at New Street, we had the whole floor, what they called it was the old car park level, throughout the structure that had to be removed. Now, by doing so, you're changing the column length from 1 story to 2 story, which required temporary bracing to control. When we did the analysis of the structure, it required some temporary bracing to go in. Excuse the quality of the drawing there. I'm not sure why it looks so rough, but it does. It's quite an old drawing though. But something had to be considered. Similarly, this is Centrepoint in London with John F. Hunt. So here we were taking out the red, which is the floors and the beams that tile the columns together. You've gone from an effective length, which is 1 story, to a 3-story effective length for these columns here. Again, you've got to think about that and have a plan in place to either prove that the column will work like that, which in this case it wouldn't, or put in temporary bracing, which is what we did. You can see there's quite a lot of significant temporary bracing. And clearly I've grabbed an older drawing. No, I haven't. No, they are super slims. They are super slims. And you can see super slims, 2 sets of super slim bracing on the columns there. There you go. You can see the full height there to brace those columns in their weak axis. Clearly had capacity in the strong axis, but in the weak axis, they needed bracing up because you're at the bottom of a 30-something, 32, 33 story tower. That's just another picture of it. It was quite spectacular, that job for the temporary works, and the cut and carve that went on that scheme was quite significant. So this is a bit higher up the tower, where we were taking out floors. It was that drawing I showed right at the beginning, where we were taking out the floors at the top levels, level 33, 34, 35, yeah, roof 34 and 33. And again, significant temporary works were required to keep the structure stable as the demolition works progressed. All sorts of propping and stability systems were installed in that structure to keep it stable. There is, again, significant temporary work, significant cut and carve on a very challenging site, that one. This again, looking at stability. So this is City side, a John F. Hunt job again. Here, there used to be, I can't remember if it's lift shafts or if it was masonry. I think it was masonry cores and light wells, which gave a degree of stability to the structure. On this one, the Permanent Works designer had said where they wanted the temporary sway bracing putting in, which is, you can see there, those blue and red dotted lines. So that's where they were put in. And then we did the detailed design of them from there. Again, so fairly simple bracing that works in compression or tension all the way through the building in the position as shown there. And this one also, as we were taking out columns and slabs and all sorts, there was a lot of vertical propping that went in as well. So you can see there's a propping there, propping underneath here, propping here, propping over here. And there was also facade retention of the top 2 floors. So you can just see the facade retention there peaking on the top of level 3. So you had 2 stories of facade retention at the top of the building, and then we had all sorts of bits and pieces going on with beams being removed, columns being removed, walls being removed, slabs being removed all over the place, and there was a lot of propping that went in. And again, because we were mindful of the loadings and the deflection in the long term, we've used a higher capacity system all the way through to try and limit deflections of the slabs. It also brings about interfaces. So as I said here, we have facade retention, sway bracing, vertical propping, and in this corner in particular, you had 2 lines of facade retention sitting on top of vertical propping through the height of the building, and then you had your sway bracing there as well. So it really pays to think these things through and make sure you've got everything covered before you go charging off. And then we had this facade here, had the slab taken out, and that was restrained all the way up the building as well with a simple knee brace type system. As I said, the follow-on works is often a change in the contractor, though not always. It's a potentially dangerous handover point. You've got to make sure that they know everything you know about the structure. The other thing that often crops up is there might not be a specification for the demolition works that limits deflections and movements of the structure and things like that. Whereas the contractor who's building or carrying on building the next phase will probably have limits on slab tolerances, slab levels, those sorts of things. So it can be a bit of a tricky point if that hasn't been considered during the demolition stage. You also find cut lines change as the design develops. So you might have put in all a nice set of props and worked it all out, and the cut line changes as the design develops, which can cause problems, design developing generally. And there should definitely be a formal handover of design documentation between the contractor, between contractors, and that's specifically with drawings and the DRAs, so they know what's been done. And if there's any as-built of the temporary works that are installed, if they've changed from the design intent, that should be recorded and should be handed over. Interestingly, the one at Cityside House, we actually worked with John F. Hunt, the demolition contractor for the works, and then when it went to the construction phase, we carried on working on the scheme for Elmers, who were doing the construction phase, and we did a whole set of reviews and analysis and drawings to indicate how to work with what was already there and make it work with the permanent condition, which was kind of a point that was missed out of both contracts. So it went through and explained, looking at how Elmers wanted to build the building and how it was already sitting, how and what they would need to do to keep it stable, and also to make sure deflections sat inside the specification for the works. That's just an example of one of the schemes there on that knee brace, the front facade that was in. And that brings me to the end, short and sweet. If you want to know more, the Temporary Works Forum is highly recommended. 5975, the book Temporary Works, Principles of Design and Construction, the NFDC website and the IDE website as well all have information on all these sorts of things and are worth flicking through. So my contact details are there, and we will now move on to the Q&A.